Alright, so number 58 in 11.2 is asking to find the values of x for which this series converges, and then find the sum of those corresponding series for the converging values. So, to do this, this is a geometric series, or the form of a geometric series. And we know that for a geometric series to converge, the ratio between the terms has to be less than 1, strictly less than 1. Alright. And if we look at this, our thing raised to the exponent of n, or n minus 1, but in this case n, is x plus 2. So this is indeed our ratio, and we're going to set that in absolute value less than 1. And if you remember, when we have those, we could write it as a compound inequality, basically saying the distance in each direction, so the negative and positive distance. And then we can subtract 2 from each side, and we get our interval of convergence is what it would be called. And that is from, well, -3 to -1. So basically what that's saying is any value in between -3 and -1 non-inclusively, when you plug it into here, is going to create a geometric series that does converge. And now from there, we can actually find the sum. So the sum of a geometric series is a over 1 minus r, where this is the first term. So we've got to be somewhat careful here with our series because it starts at 1, but the exponent is n rather than n minus 1. So that first term here is not just that coefficient that we usually see, but rather it is x plus 2. That's just that comes from plugging in 1 to the exponent for the first term. So our a is x plus 2, and we know our ratio is also x plus 2. So this is our sum, and that is the answer. But let's just check a value in our interval to make sure it does indeed converge, just to double check, right? So let's pick x to be -3/2. And this is not necessary, but just to show exactly what's going on. So if we're taking x to be -3/2, the series becomes -3/2 plus 2 to the n from n equals 1. Which is the same as 1/2 to the n. So that's a geometric series, clearly, and it has a ratio of 1/2. So if we were to do the formula, a over 1 minus r, our first term, again, plugging in the 1 here, is 1/2, and then the ratio is also 1/2. So what we get out is basically 1. So this series at x equals -3/2 converges to 1. Now, if we were to plug 1 into our formula, what do we get here? Let's double check. This should also give us 1. Well, we get 3 in the numerator. Oh, I'm sorry, not plug in 1 in the formula. We're plugging in -3/2, this value. And we're seeing that it converges to 1. So we're plugging in -3/2 plus 2 over 1 minus -3/2 plus 2. And we see what that's equal to. Well, the numerator is 1/2, and the denominator, this amounts to 1/2, 1 minus 1/2 is 1/2, and this is again 1. So this general formula works for all values of x within this interval. And in this case, we just checked 1 specifically. And you could also check values outside, and you would see that this value is indeed greater or equal to 1 and would not work. So yeah, that's the end of that.